All right. Hello. Good to see you. Sorry that I missed you on Tuesday. I mean, I did miss you on Tuesday. I'm sorry I wasn't here. I'm not sorry that I missed you. Okay, so high-level logistic things off the bat. We'll be releasing homework 1 later tonight. I've got to get the system all set up. It will be, the first one will be mainly a coding exercise where you'll be implementing a crazy policy that I give you. All revealed. It's kind of intentionally obtuse and not super crazy, but just in a way where you have to actually think through what are the intentions behind this security policy. And it's going to be themed around kind of the house scenario that we've been talking about. So that'll be first homework assignment. I'm sure you have a lot of questions, but let's save it so you can actually read it. Then you can hop on the piazza and ask all the questions to your heart's content. Any other questions not related to that? All right, cool. So did anybody solve the assurance problem while we're gone? Do you have a question?
Oh yeah, I was going to ask when it would be due.
Yes, I think probably a week-ish because it'll be a pretty simple first assignment. Cool.
What did you say about this assignment?
It will be released tonight and all the details will be there.
Oh.
Cool, okay, so assurance. So how do you quantify assurance? Yeah. Testing. How does that quantify it?
Because you can validate whether your system is secure by launching a series of like test attacks.
Okay, so you can create test attacks, but how do you, so with quantification, you want to bring it down to a number. So how do you then trust, do you trust the system 50% because of your test cases? Do you
That's
trust it
up to discretion, I guess.
Say again?
That's up to discretion based on like whatever's required. So if, like healthcare, I guess, could be much more specific where you need like 99% of your test cases to pass versus something else.
Unless that 0.01% is the test case where somebody dies, right?
That's true.
So yeah, but context is incredibly important, right? It depends on what you're trying to build. If you're writing software that keeps airplanes in the air, we would all agree that you want a high level of assurance there that those actually work. So you may not be acceptable with having 10 test cases and having all those test cases pass and just say, yep, looks like everything's good. I 100% trust this system. Right? Whereas other situations, you maybe don't have that kind of requirement. Is there a hand in the back? Want to share? For a person attached to a hand that wanted to share? Yeah? Was it you? You wanted to say something? Okay. Next time. Cool. So what does it depend on? So what, when we think about assurance, what does our trust in a system depend on? So we talked about test cases. We can create some kind of test cases, which are really testing that the system does what we think it should. But what does that really depend on? Like what are all the factors that goes into developing a piece of software? Now I just completely changed what you're going to say.
Well,
Yeah.
I was thinking like
It's okay.
maybe what's the acceptable risk?
Ooh, acceptable risk? Why is that important?
I guess in the sense that how much damage you can do.
Right, so when you think, so it goes back to context again, right? So not only what's the software supposed to do, but from a business perspective, what are you most concerned with in terms of risk, right? Are you worried about losing your customers' data, which would suck? Are you worried about somebody arbitrarily changing your customer data, right? What is the risk that you absolutely like cannot tolerate? And so you want to think about it in those terms. So yeah, so risk, if it's not a risky part of your system, you may be okay with a level of assurance that's like, it's probably going to work, and if it doesn't, the risk to us is very minimal. So what else does assurance depend on? What do you want to be sure is correct, or that you want trust in being correct? Yeah.
That the way we're approaching our system is the way we want to be approaching our system.
Okay, that the way you, can you clarify a little bit?
So if we're talking about like a house,
Mm-hmm.
you know, the way I'd approach securing a house would be different from how I might secure an apartment building.
Yes, okay, so making sure, so this is part of assurance then, making sure that what you're testing is appropriate for the system that you're actually testing, right? Because yeah, if you apply housing tests to an apartment, then that maybe doesn't make sense, yeah?
How about trusting the people that handle the data?
The people that are handling the data, yeah, what about if we think about the system itself? So we think about less of the data and the systems around that data, like the software systems. So how do you write software? Has anybody written software? Everyone looked at me. So the typical way is that a professor gives you an assignment, you go, you wait till the last day, and then you start working on it. You start just trying to furiously code something that works. How should the software engineering process work? Yeah,
A lot of planning.
planning. So what do you do in the planning phase?
You design the system, and then you design how the system should interact.
Right, so you build a high-level design of what are all the different components in the system, how do they talk to each other, in what ways do they talk to each other, who's responsible for doing what. So you create some kind of a design, which you're still, although I guess technically, in most homework assignments, that design is kind of handed to you in the form of your specification. So what else? Then what do you do? Magically code appears. Yeah, so you work on it, or you implement, you have to actually implement that, and then what do you do?
Test.
Test. So you need to test that. So when you think about the assurance of the system, you want to think about that at all of those different layers, right? Is the design correct? Right? What if you're building 100% perfectly something to secure an apartment, but you really care about securing a house? Right? So if the design fundamentally says something like, or the specification, if the specification says that, well, anybody should be able to enter this house at any time, but you as the business owner do not agree with that specification, then whatever gets built at the end, it doesn't matter that it matches the specification, because the specification doesn't match your business objectives with what you need and what your security policy is. So specification really tries to answer at a high level, and this isn't a software engineering course, but it's important to think about that. And what I want you to be thinking about is it's not just the end stage. You're not just testing that software component at the very end, right? It's important to think about, when you're thinking about how much do you trust the system, did you verify the design, or did you actually analyze the design or the specification of the system? What about the design? What about the implementation? What about while you're developing the system, are there tests? Are you testing it for security? Or do you just wait till the very end? And then all the bugs get swept under the rug because we've got to ship tomorrow because the CEO said we're going to ship tomorrow, so security bugs be damned. So how do you define specifications? Yeah.
When we define specifications, we first have to look at what we're trying to do first.
What you're trying to do? Yeah.
And then there we get into a little deeper. How can we protect this, like reports from hackers? How can we protect the doors from being tapped into?
But how do you actually define, like what does the specification actually look like?
So like maximum, like how big is the room, how much are we gonna fill the space?
Yeah, I mean those are all types of specifications, right? So you think about the house, the specification could be the building plan, right? What about with software? Yeah.
You can use like text or diagrams.
Yeah, text, I mean, it's kind of what we talked about when we talked about security policies, right? So you can use text, English text, to define your specification. And this has basically all of the same drawbacks that we've been talking about with actual English specification. So what are some of those drawbacks? Yeah, go back there.
Ambiguity.
Ambiguity, right? This happens actually all the time. If you look at, there's actually a whole class of vulnerabilities that exist because the, let's say, specification for HTTP doesn't say what to do in this certain scenario. So two implementations do it differently, and now you have kind of like this broken ecosystem, which can lead to security problems. What are other ways to define specifications? Yeah.
You can use like expressions, like mathematical expressions.
Yeah, so we can do mathematical formalisms, right? And then that has all the downsides we talked about already. It can be difficult to understand. It may not accurately reflect what you're trying to do. But the nice thing is maybe you can actually verify that the end system satisfies your specifications, right? There's a whole area of system verification, like automated verification, that basically you write a specification and then you can verify that the program actually implements that specification correctly. Of course, then you have the problem of how do you know that specification is actually correct for what you want to do, right? So you can verify that there's no bugs in the implementation that don't jive with your formal definition of the specification, but fundamentally the specification's wrong. If there's a bug there, then you have the same problem. So we take it to specification. This says basically what we're supposed to do. Then we sit down, we design a system. So when we design a system, what are some components that go into that? Yeah.
Well, like what the specifications are?
Like, say that again?
What the specifications are?
Yeah, so your design is based off of the specifications, right? So you take that in, and the whole goal of the design is to design something so that it matches the specifications. How do you go about doing that? I'm gonna try calling someone new. Yeah.
Implement the mechanisms that are hopefully defined in the specification.
Say it again, louder.
Implement the mechanisms that are hopefully defined in the specification.
Yeah, so implement, so go through the specification. You're trying to understand, so the specification says what the system does, is supposed to do. The design specifies how it should do that, right? And so it's actually, and how do you actually, so if you're talking about assurance, so you have the problem of is the specification itself correct with what the business wants? Then you have the problem of how does the design, how do you know that the design actually matches the specification? So how do you do that? Is it important to do that?
Yes.
Why?
Well, if you design a system that doesn't satisfy the specifications, then what's the point of the system?
Exactly. And maybe it does 90% of that functionality. Like, oh, you didn't say that you didn't want a backdoor in your system. And this seems like a crazy thing, but I mentioned we all have routers at home that have default username passwords, which is essentially a backdoor installed by the people who manufactured that system. Right? If you're a business, you definitely don't want that, right? But as users, we actually do want that so we can go in, log, and change our SSID to something clever. So how can we actually verify that the design satisfies the specifications? Yeah?
Try out test cases.
Try out test cases on the design itself, right? So this can be slightly difficult because your design may not be executable, right? So what kind of formats are the designs in? See if we have any future PMs in the audience. Yeah.
UML models?
UML models, yeah, so you can have a more formal UML model that diagrams the components in the system, how they relate to each other. I'm not aware of places that actually use that, but I would be interested in learning if you come across any.
Waterfall models?
What was that?
Waterfall models?
Waterfall. So waterfall, I think, is kind of this whole system we're talking about, right? Of like specification, design, implementation, testing. That's really, I mean, you can think of this in the agile model as well, right? Which is your time scales are crunched down. So, yeah.
What about Simulink models?
Simulink models. What's Simulink? I'm not familiar with that.
Like MATLAB?
Oh, MATLAB models. Interesting.
Partitioning and capacitance history.
Huh. Cool. Is that useful? Have you used it?
Yeah, for my internship.
Okay.
That's how they did it.
Oh, interesting. Did you find it useful?
Yeah.
Okay, cool. That's the important point. Okay, so yeah, we can chalk those all up to some kind of modeling way. So you either have UML, I mean, you can model all kinds of aspects of the system. What are other ways? Yeah?
Use cases.
Use cases. So you can specify use cases of what the system should do, and this is actually very similar to the agile model, which has a lot of these where you create use cases, you even create different users and different classes of users and say when the user X does this, then Y should happen. Yeah, but they're all in English, right? Yeah. What are other ways? Yeah.
User feedback?
User feedback. Ooh, is your design itself user feedback? How does user feedback impact the whole process?
If I deliver a product after doing my own testing, and the customer comes back and says, well, all of these features were nice, but could you add this in or remove that? You know, I can't just say, well, the design said this, so
Yeah,
go
tough.
ahead.
Tough, buy it anyways, right?
Yeah.
Because you like me.
Yeah.
Yeah, so that, I would say, rather than the design itself, that kind of feeds back into the specification. So that's kind of the creating this loop, right? That's the whole idea with Agile, is you shorten that time process to on the order of weeks. That way, every 2 weeks, you're getting user feedback, which is helping you refine your specification, which changes your design. But you may need to I mean, this is kind of going slightly off topic, but you may need to understand how frequently that's going to happen, because that can impact your design. If your design says we hard code everything exactly like these, and we will always have 5 modules, and you've hard coded it throughout the entire code base that there are these 5 modules, now if you need to add a 6th and everything breaks and blows up, you didn't think about actually changing that design in the future. Yeah.
Does it say comparing to like industry standards? So like if you're a bank or something, make sure that you have these, security implementations in place versus somebody who's like an email provider or something.
Well, your email provider's not important.
Well,
Would you let me into your
maybe a
Gmail?
wireless number provider.
Wireless number provider, man. You guys start going lower. Those are all super important places, I think. But the point is well taken. So yeah. So thinking about when we talk about thinking about assurance, we want to understand based on the context what level of analysis of the design is appropriate, right? Because we want to fix problems here. So nobody caught on to my favorite answer of how designs are done. That's with PowerPoint. This is a life. I have a friend who is oh man, maybe I shouldn't start calculating because I'm going to feel old, but he's been a Microsoft PM for, I want to say 7 or 8 years, and his entire job is basically PowerPoint. So he's the one who talks to the users, figures out the specification, and kind of creates PowerPoint documents that become the design. Or, more on a technical level, is a Word document, a text document describing what the system should do. So very similar to kind of the use cases of how you're specifying that. So then we get to the problem of testing or thinking about the assurance. How much do we trust that the design properly implements the specification, right? So you use all the techniques we talk about. We can hire somebody to essentially, even if it's not executable code, to still pen test this design. Is there a way from this design to do something bad? If it's bank software, can I get it to transfer money out of an account? If it's email provider, can an unauthorized person get access to the system? And can we prove it? So you tell me your design 100% follows the specification. I say I don't believe you. How do you prove it to me?
We run tests.
You show me your tests. I say your tests are garbage. Why did I say that?
Because we failed.
Maybe they failed? Okay, if you try to tell me your system's secure and your tests are failing, we're already in a bad place.
Do you use your program to test it?
You could give me the program. You could basically say, well, come up with a counterexample where the system does not. I'm busy, I don't want to do that, but I don't trust it. Yeah.
You could hire a third-party company to provide like countermeasures, or like show how they attempt to break in, and then
Did you ever prove it? Like 100%? Yeah.
This isn't like a math proof if you're looking for that, but you, as the designer of the specification, you could make your own test suite.
Interesting. Okay, so separate the concerns. So if you're in charge of the specification, but you're not in charge of the design, then you could separate those to make sure that you write test cases. That's a good way. Does that still prove anything?
There's
Yeah.
couple methods.
Yeah, how do you do that?
There's languages. I don't know the specific.
Right, so then you'd have to, you can do that. You need to formally define the specification in a formal language. Then you need to have your design also in that formal specification, and then you can mathematically prove that the specification matches, or the design matches the specification. The problem then is, well, how do I know there's not a bug in any of your modeling components, right, of the design and the specification? Yeah.
Where I was working this summer, like pretty much every job we'd get handed, the company would also have like basically a whole battery of unit tests, and they would say, all right, like literally it would be like, here's the design doc, and then like here's the checklist of everything we're gonna go through. Like make sure you it succeeds on every single one of these, and they would basically have their own unit tests for whatever system they had us design.
Nice. So it's almost a little bit at the second level, right? So that's making sure that the implementation matches your design. But it's that similar idea somebody just mentioned about basically have the person at the upper layer write the test case that should pass for the next layer, right? So that was talking about have the specification person list out design test cases that should pass. And then at the next level, it's to make sure that the implementation matches the design. You have the designer write out test cases that should pass. Any other thoughts on this? Yeah?
It's pretty close to impossible to truly write bug-free code.
Yes, I agree. I'd say it's, with all of our knowledge now, I feel very confident saying that it's impossible. Yeah?
Do you think, like, that we can create computers that can write bug-free code?
No. Who wrote those programs?
Really? You don't think we can write computers that can surpass human intelligence?
I don't think it's a matter of intelligence, more so that it's a matter of, it's basically, the problem is, it's turtles all the way down, right? So you have a system writing code. Who wrote that system?
A human.
A human. So there's got to be bugs in that program, which means some of the programs it generates are going to have bugs. I think on, well, the simpler things are much easier to convince yourself that they're actually bug-free. But the problem really comes in, the complexity in my mind really arises when you have systems talking to each other and you have a big complex system. So you can verify each of the individual modules. So this module is 100% secure. You put them all together and there's some complex interaction that you never thought of that is a security problem. We'll get better, I think. It'll be a lot better. But it's like anything. It's like thinking about Microsoft in the early 2000s, there was, I think almost like every month, there was some new virus or some new worm that was spreading, Slammer, Code Red, the Melissa virus, all these things. And it's because Microsoft had never really thought about security to that point. And they didn't realize that as the operating system that 90% of people use, one bug in their system means that basically the whole world is vulnerable to this. So they actually took a really hard look. They developed this secure development lifecycle, the SDL, which you can go look up. Maybe I'll have you look at that at some point. But and they took security seriously, and it took a while for that culture to be ingrained. But they basically do, and it's part of the secure design lifestyle is doing what we talk about here is like, if they do red team at the design stage of like all Microsoft stuff. They do red team reviews of specifications, design, implementations. They have whole teams dedicated to that. So it's all, you know, now we have other problems, but we don't have this problem of you're worried about a 0-day in your Windows machine that somebody can remotely get root access to. Yeah.
Red team?
Red team, like we were talking about with the penetration test, so a separate team that does a security analysis of the design and tries to poke flaws in the design. And the important thing is doing that at every stage. Yeah.
As far as proofing goes, you have to also consider that you're limited by the multi problem. But it's actually undecidable to prove any non-trivial property of any program. So for any arbitrary program. So you could do it on a case-by-case basis, but that's exhausting.
Yeah, the key, I mean, this is part of what makes my research so fun, is that the problem of find all the security vulnerabilities in a given program, and only those security vulnerabilities, is equivalent to the halting problem. So you fundamentally can't. You have to develop a system that will either miss some bugs or report some bugs as vulnerabilities that are not vulnerabilities. So yeah, it's tough. Yeah.
So I can think of the other things, maybe like do simulations.
Sorry. So you can do simulations. Yeah, I mean, there's techniques to. It's all about improving assurance,
And
right?
also you can open source the design and just put it out there.
So let other people find bugs.
Yeah. So provide it for a while.
Yeah. So I don't know if we'll talk about specific bugs, but there was a bug a while back. I think in 2014 called Shell Shock, which was in Bash. This was essentially this crazy feature of Bash. Everybody know Bash? Your handy terminal or shell, I guess is the right word. You know, you can define variables in Bash. You ever do CD tilde? How does that know where your home directory is? Magic. It uses an environment variable called HOME, all capital, that it takes you to. And so tilde just expands to this home variable. So it turns out Bash had this feature for 20 years that if you defined a variable that, I think it was the value is, if it was a bash function, it would execute that function. So that this way you could pass functions from one bash script to another in the form of environment variables. This had been happening for 20 years. And finally in 2014, somebody realized, hey, that's a security problem because some applications like any CGI web application, some things like Ruby on Rails, the user can actually create environment variables that Bash would then interpret and execute. So this basically gave people remote code access on like millions of machines. So it was a huge deal fixing that. And that existed in an open source package, Bash, for 20 years. So open source is good, but it's not a, I think, what's the phrase? There's the open source phrase about many eyes find many bugs, I think, or something like that. But other people have amended that to many eyes find shallow bugs because you have these really complex vulnerabilities that exist even in open source code. So this was a good discussion. So really, and this is what I want you to be thinking about is if somebody is trying to tell you that something is 100% secure, you should not believe them. Right? They don't have a proof of that. And even if they did, it's hard to trust those proofs because what's the language that the proving system was written in? What's like, how expressive is it? All this fun stuff. So then it goes to the part that, it's not my favorite part is implementation, right? You're writing all the code. So how do you actually implement the design? Seems like a silly question. It's not a trick question either.
You write code?
You write code. So you read the design and you write the code. Is that it?
Make sure all the features are working.
So, but that's, well, that's how you know that your implementation is.
Maybe not working, but like you implement all the features.
Yeah, but you write it, right?
Yeah, you just code all the features.
Write the code, you terrible humans that insert security vulnerabilities by accident. Not you, all of us, including myself in that, right? Yeah.
There's probably different stages of implementation you can set up, like stage gates. So you have your first stage being very simple, and then you move on from there.
Okay, so you could basically take the design, group the features that you definitely want to do, and create kind of, rather than trying to write the whole thing at once and then being so shocked when it doesn't work together, write small pieces like a core component and kind of build out from there. What about automatically? Wouldn't it be super cool if you could not code? Where was he? That guy wanted to have computers write programs, so he wants to put you out of a business. So, and this could, if you had the design in a formal specification, you actually maybe could do this, right? If you have some formal design, you could actually have something that spits out code that matches that design, and maybe use that as a starting point. But how do you know that the implementation satisfies the design? So we've talked about this a lot, but let's kind of talk about all the things that we've discussed so far. So somebody mentioned that we have the person that created the design create test cases that you are either executable or not. Maybe it's just a table of test cases. But what else? Is that the only way? Yeah.
Well, there are different ways you can test it. Like you can do unit tests on individual classes or modules, or you can do like a system level test.
Yeah, so you could do unit tests, which is touching like an individual function or module. You could do more broader integration tests, which testing or system tests, like test the system or other components end to end. Does that still mean that your implementation 100% satisfies the design? Yeah?
Well, it needs to satisfy the specifications, right?
Ah, yes, it does need to specify the specifications. So this is also part of assuming, right, at every layer. If you're just doing what the design says, but the design was wrong in terms of the specification, then you're building the wrong thing. But let's say that the design is a faithful representation of the specification for now. So just considering, so think about these as like different layers, right? So just considering the interaction between those two layers. Is that a hand? I guess not. Any other thoughts? Yeah.
So I say have some sort of like beta alpha testing or something?
Yeah, so then kind of similar to the staging idea of basically don't build everything at once, build a small piece and then release that or test that, release it to customers, maybe do a pen test or have a red team review of that right then, and then build out from there. Again, we come to the problem of how do we prove that the implementation actually satisfies the design? Yeah.
The stakeholders say so?
The stakeholders say so, yeah. That's a very software engineering point of view. I mean, at the end of the day, I guess if somebody's paying you to do it, then and they say it's good, then it's good. At the same time, they may not have the expertise to identify all the security vulnerabilities that you accidentally left in. So just because they say it's good, I guess from an assurance perspective, maybe functionality is good, but then when you think about security assurance, then you may not use as a trust indicator. Yeah.
Is it going to be very similar to the last thing, or how we, how can we prove the specifications where like we can't 100% like prove this, but we can go through like different testings and different releases.
Exactly. Yeah. So we need to somehow convince ourselves, and it's through these types of processes that we've talked about of doing red team review, including testing. Oftentimes, and this is actually something that I think came up about a year ago, so I don't think I included this, but one of the things, so oftentimes, so people worked at a company, done automated testing. What were your test cases testing for? Yeah.
That like the individual components satisfy, they do what they're supposed to do, that like data flows through the system correctly.
Yeah. So basically, I mean, it depends on exactly what it is, but essentially you're verifying that the design, that the system does essentially what the design says it's supposed to do. How many of the tests test what the system is not supposed to do? You have test cases that test for null pointer errors, or test cases that give, I don't know, 60,000 bytes as input to see if any buffer overflows are triggered. Do you have test cases that test if, have test cases with SQL, like special characters, like single quotes, to see if any SQL errors are generated, which could be an indication of a SQL injection vulnerability? Yes? No?
You could do that, yeah.
You could do that. Do companies do that?
Some.
Huh?
Some.
Some, and I think, and I don't know if he wants me to name him, so I won't say who he was or where he was from, but this was actually a really interesting idea of basically automating security testing and putting it into your testing pipeline. So that way, rather than have it be this thing that humans do at the end, actually have test cases that are dedicated to security parts, right? And it's, again, a very difficult problem because it's not a positive test of saying, does this function or does this module do what it's supposed to do based on the specification, yes or no? You're trying to prove the absence of behavior, right? Is there a security vulnerability here? And so proving that with test cases is very difficult, but yeah.
So sort of proving what happens when something else breaks in your program.
Exactly, and so thinking through, and the difficult thing is creating this in an automated way, but you can do it, and so it's just something I want to expose you to be thinking about. Because, and yeah, even the implementation, you know, is a difficult thing. And the other thing to think about is, I think we touched on this briefly, is how do you even know, so you're probably looking at the source code, but how do you know that the compiler didn't accidentally introduce a vulnerability? Do compilers do that?
Yes.
Yes? How? Bad compilers. Yeah.
Their specifications can be ambiguous in like certain edge cases. So like if you don't declare an initial value for a variable, what does it become?
Yes, it's whatever garbage was in that memory location previously, right? So I've seen specifically actually the reverse of that, where somebody, I think it was, I can't remember what application, but it had in memory the user's password, and so they had a line that zeroed out the user's password. But the compiler, being very intelligent and optimizing the code, said, well, this password is never used later on in the program. So why zero out the password? That's just a waste of time. So it knocked that instruction out, and that didn't actually get included in the binary code. And so then you had a vulnerability that existed only in the binary version, but not in the source code, because the compiler is being too smart. So to make this problem even more complicated, you have the problem of, does your source code match the design? And then, does the actual binary that is running on people's systems match the design? Match your source code and match your design, ultimately at the high level. Cool. So really the point of all this is to get you to think about how difficult these problems are. And then, not even to stop there and to think about, well, now you wrote some software, now you have to deploy it, you have to configure it, and you have to operate it. Are these all areas that can impact security?
Yes.
Yes, very yes. Right? So now you have to ask the problems of, well, how is this being deployed? How's it being configured? How's it being run and operated? Especially when you want to think about security, if you're talking about access to user data, the system itself maybe is 100% secure, but if everyone in your company is admin on the server where the user's data is running, then that's a horrible problem, right? So, and this is really what I mean, this is why I love security and why it's so fun, is all of these things have to actually be correct, right? You could have a security bug at the specification level, design level, implementation level, deployment, configuration, and operation level. And so you actually have to, as an attacker, understand all of that in order to see how it's supposed to work and to see if you can exploit any vulnerabilities. And then the cool thing from the defender's perspective is you got to defend all of that, right? You have to make sure if you want to create a secure system, and I said you can't create a secure system, if you want to have a high level of assurance that your system is secure, you need to make sure that every single one of those levels is taken into consideration. Yeah?
Have you ever seen bugs cancel each other out? Like, there was a bug in the implementation, but then, like, the way it was deployed, like,
oh, yes,
covered
actually,
for it, or...
yeah, and I actually have an example right from DEF CON. So the way everything worked is we had basically a central, like, database that had a REST-based API so that all the other components could talk to it, and they would log events like, this flag was captured, or this thing was done. So everything would feed into this REST API. And then, as I was doing this, I realized, wow, I'm going to be the only person who can ever use this thing, and I don't want to interact with this REST API directly. I want a nice, like, admin interface so we can do things like release a challenge or release network traffic to the teams. So I coded up this really ugly admin interface that actually used the REST API. And while I was doing this, so we were doing this in a Kubernetes admin cluster, and I changed, so my original security design was the REST API should only be accessible within this admin cluster. Nobody else should ever be able to access it as a layer of defense, so if the teams ever did something really weird, they would never be able to talk to it. Then I realized, well, I want the rest of my team to be able to access this, so I used the option to expose it on a node port on port 30,000. So we had 2 machines that were part of this Kubernetes cluster. If you made a request to those machines on port 30,000, you would see this admin page, which by itself is fine because the teams could never talk to that IP address, except that they needed to be able to access a team interface, and it's getting very complicated now, but essentially so this, one of the machines had basically was impersonating an IP address, so it had 3 IP addresses. One was this team interface. I didn't realize this stupid node port was binding to all IP addresses. I thought it was just its internal IP address.
Yeah.
So the teams would access the team interface, and because I didn't restrict what port they were accessing, which is another problem, they could scan that IP address, see that port 30,000 was open, go to it, and actually saw the admin interface. So that was a huge bug in deployment, and probably configuration, because I configured it incorrectly. And so we actually did, and it was like that for probably 3 hours, and it turned out that, we got some early warning signs because some of the teams were coming up to us saying, hey, I saw a service appear and then go away. We're like, that's weird, what are you talking about? That didn't happen, get out of here. And then finally another team came to us and said, yeah, we found this admin interface that doesn't look like it's part of the game, you should fix that. So then we blocked it and we found out that another team had found the admin interface and was using it to toggle some services as visible or not, which appeared to everyone else. So, talking about bugs canceling each other out, I didn't have enough time to write any documentation about how to use this REST interface, which is really good because they weren't able to figure out how to add events to give themselves more points. So all they had was basically a status of the game and a way to change services as visible or not, which is not very important and it doesn't give them much information at all. So it was not as bad as it could have been because there was no documentation. So that bug of me, and I literally had a bug in our GitHub issue thing of write documentation of how to use this API, and I just never did it. So yes, it was a huge security through obscurity situation. So long story.
So we should just make all our code too difficult for anyone to use.
Interfaces. I think the interface was so difficult to use
Just
because
really bad UX design.
It's an API, right? APIs are complicated, right? How do you make a general purpose event API where you can log events? But yeah, in general, documenting APIs is difficult, and everyone on the team had, so the moral is don't write documentation. Definitely write documentation, write clear user interfaces. Make sure you secure things is the appropriate response. Cool, so then, again, we have the problem of so we've implemented something, we're fairly sure that it's implemented correctly, which means according to the design and the specification. But now how do we prove or test that the deployment configuration and operation is actually secure? Yeah?
You can monitor it.
Monitor it, so put monitoring into place to seeing who's doing what. Yeah, so that way you can actually respond to that and try to recover. Yeah.
That why Google Chrome and stuff have those feedback programs.
Yeah, this is actually a really difficult problem for people shipping desktop software. Right? How do you know? I mean, they're looking for more bugs than anything else, but yeah. So how do you get actually results back from some user's machine? So that's why Chrome, Firefox, all these things have options to report to them. And Chrome's even taking it farther and doing things like report to us if there's a weird SSL error, because maybe somebody's impersonating and stolen some security certificate. What else? Yeah.
We can do penetration testing at any of the last 3 steps.
Yeah, exactly. So you can do, and this would be different, right, than the implementation, because against an implementation, you maybe are just have a binary, maybe you have access to the source code, trying to find bugs that way. But here you're actually trying to exploit the system as it is deployed, configured, and operated, right? So this is actually why most penetration tests happen at this level, right? Because if a penetration testing team finds a vulnerability and is able to exploit your system as it's deployed, configured, and operated, that means that a bad person, like a hacker, can do that as well, right? Which, like we talked about things canceling out, maybe, so when you can find at the implementation level, maybe problems, but maybe how it's deployed actually isn't a problem, but you still maybe want to fix that. So how expensive is it to fix problems at each of these stages? What's the cheapest? Huh?
It's the cheapest if you fix it in the specification.
Why?
Because you haven't done anything. I
Yeah.
mean, you've written
Well,
the specification.
Assuming you find it at that stage and not when you've gone through the whole process. Yeah.
So it's cheaper to fix problems that, like the earlier in the process, because each layer has to be like satisfied by each pre-existing layer.
Exactly, and you may need to completely redo, right? You may find such a bad problem in the specification, we have to completely rethink the design, which means you have to more or less throw out a lot of your implementation and redo that, right? So it's incredibly expensive. This also extends when you think about just implementing. It's a lot cheaper to fix a bug on the 5th day than it is on the 100th day or 300th day. Why is that? Anybody work at a company with an old code base?
Different people are there now, or
What was it?
different people are working there now?
Oh yeah, that's, I mean, a huge problem,
Larger
right?
code.
Yeah, so you have the code more or less gets more complicated over time. Things that were good ideas at the time turned out to be not so good ideas because the specification has changed. The code is brittle, and you change one piece and another piece breaks, and you have no idea why. Right? All these things make it really difficult. So, and people often forget this. Like, there was a lot of hate for a long time on Microsoft about people would report vulnerabilities in Microsoft and then want to release the details about that exploit within 30 days. And Microsoft would always push back because, for security researchers, it's difficult to understand, but anybody heard the idea of a test matrix? It was just a table of all the combinations of operating systems and hardware or whatever that you need to test in order for something to pass. So when you're talking about, let's say you find an exploit that affects all the way back, what's the least supported Windows? 7 still supported?
7, 2003 started support, but still used.
Oh God, that's terrible. So let's say, let's make it really bad and say, yeah, all the way back to, let's say, Windows Server 2003. Is that also with Vista? I don't really remember all my Windows, but the last.
XP or something?
I think XP is finally end of life, but let's say everything after XP, you think about every single operating system, that whatever change and fix, no matter how minor, they need to test on every single version of every single operating system that has been released since then, on also different types of hardware with different types of software configurations, because something weird can break. And so that testing takes a lot of time, even if the fix itself is very small. So this is something to, I don't know, keep in mind that testing, finding a bug in a deployed system can be very difficult because you need to test it and reevaluate it. Have you heard about SimCity? Do you know SimCity?
The game?
Yeah, the game. Yeah, so this is a really interesting, I think, his first name's Raymond, I can't remember his last name. I think Chen, C-H-E-N. He's a Microsoft engineer who has a really good blog about the early days of Microsoft and Windows. So when they first moved, I think, to Windows, I want to say 95 or something, because when you make this operating system, if your old software doesn't run on it anymore, nobody's going to buy your new operating system. And so they would test all of the popular software, and they found out that SimCity was taking advantage of some undocumented features of Windows, whatever was before 95, I don't remember. Maybe it was DOS or something. I don't know, it was taking advantage of some super weird feature. So instead of being like, SimCity, you suck, fix your software, Microsoft actually put in a shim into the operating system that says, if the program executing is SimCity, then change the behavior of the operating system in this way to support it. And you think that's just one example? So you think about all those examples over these years, it's absolutely absurd that anything still runs. So stuff's complex. Fixing stuff is hard. So, okay, so we've identified a problem. Do we fix it?
It depends.
It depends? It seems like a silly question, right? The answer should always be yes, you fix it. Your front door's broken or your window's broken, you fix it.
Am I moving houses though?
Are you moving houses? Is it somebody else's problem? Are you moving out of your apartment? You're just like, I have a landlord to deal with it. Yeah.
Or if your screen door breaks and you never use it, it's like, well, why should I
Yeah,
replace
what do
it?
you care? Your screen door is not very secure, right? How hard is it to break a screen door?
Cut it.
Hey, cut it, or just, I don't know, punch it. I don't think it's super, you've never seen a screen door that's like very secure, right? So why don't we fix it in this case? Oh yeah, please.
It might also be more expensive to fix it than to just build a new one.
Exactly. So maybe I'm trying to think of a real world example, but maybe the problem that going back to risk, maybe the risk to the company is only like $50 and you're going to spend $50,000 to fix it. Maybe it's not worth it. Yeah.
I was gonna say like more expensive to fix it than build one. Sometimes like with like cars or motorcycles that have like an engine problem or a transmission problem where it's like, well, I don't want to spend $1,000 to fix it, where I can just buy a new one.
Right, exactly. Yeah. So both very good points. Yeah.
Going back to the legacy code base stuff you were talking about, if we have no one at the company that really knows how to work with the legacy code base, it might be, and something breaks in that, but we're working on a new solution to it, might be better to just kind of burn the old system down and move to the new solution.
Yeah, so yeah, that's exactly. So for all kinds of reasons, maybe the bug or the problem in the old system is so difficult to fix that kind of makes sense when we just talked about starting from scratch in some cases. Or maybe you already were starting from scratch, right? And so you know we've invested all this time and money into building this new system. We'll just stick with the old one at least until it works. This is usually the optimistic scenario from people who've never gone through that. Because you find out very quickly that old systems have a lot of bugs that you thought were bugs that are actually features that everyone uses, and you have to replicate all of those bugs or features, otherwise they get very upset, and at the end of the day you have a code base that is just a pile of garbage to a new person because they don't understand all of those weird corner cases. So this happens a lot. It's called, I think, second system syndrome, where you build one system and you're like, man, it's a pile of garbage. I finally know how to build it right. And then you spend years building it right, and then by the time it's done, requirements have changed. Like, it's not really useful anymore. So yeah, so all this comes down to, right, and this is getting across the idea that change isn't free, right? Fixing a bug, fixing a security problem is not free, which makes sense. We just talked about when in a life cycle of a system you find a vulnerability, usually the earlier the cheaper it is to fix, which clearly is better, right? You'd rather fix a bug for $10 than $10,000 or $100,000. And so, and this is really, and this is kind of applied at all areas, and this is kind of having a discussion around this. And this is the other important, one of the things I hope you're getting so far in this course is we don't just talk about how awesome it is for things to be secure and how security is the most important thing on earth, and even though I do really like security, always have to consider the business context and the business situation, right? Do you actually want to, like, is it worth the cost to do whatever it is you want to do? If it's not, then why are you doing it? You're just wasting money. So this is something we need to, so what are we weighing here when we think about cost benefit in these terms? What are some of the things we're trying to weigh? Yeah?
How much it would, the benefit of getting whatever we fix or updated or whatever versus the amount it's going to cost. Because if it's just like a simple $50 fix, then yeah, of course we're going to fix it because whatever it is, better to ensure that it's doing that.
Yeah, so we have cost. So cost, one factor. What other factors? Yeah.
How much you value user information?
How much? Ooh, that's okay. So yeah, so let's say you're trying to weigh the downside in some sense or the impact, right? So thinking through how much you weigh user information. What are some of the things that as an organization you would think about there? Do you really just care about user information?
Trade secrets.
What's that?
I was gonna say like your reputation if that user information like was leaked.
Yeah, so your user reputation. So not only do you have to think about let's say the monetary value or how many, you could try to estimate, well, how many people would cancel accounts if we lost all their data, right? But you also need to think, do big organizations and companies care about their brand?
Yeah.
You've never considered this before? I'm not seeing a lot of nodding. The answer is yes. They have marketing is basically an entire department dedicated to brand, right? More or less. So, do they care about these things? So, oftentimes they're thinking about the PR ramifications of, do we want our brand associated with this latest breach? Like, would you buy an Equifax shirt or I don't know, another type of product? Equifax lost, what was it, like hundreds of millions of users' personal information, and I mean, Equifax was one of the major credit credit bureaus. Yeah, I think that's the term. Right? So they lost all this huge data. Like, you think about what these credit agencies know on you, it's everything. All of your accounts, to even check your own information, you have to pass a bunch of tests. So, you know, they took a huge hit to their PR when that happened. I actually don't know how it's recovered since then. I mean, I guess I didn't trust them to start with, now I definitely trust them. What other things do we consider? Cost, direct downside, yeah.
Feasibility.
Visibility? Yeah.
Feasibility.
Feasibility of the fix. Yeah, exactly. That's a great point. So if your fix, how do I try to word this? If your fix is, well, I will solve the problem of people breaking into my house by filling it with water. Right? If I waterproof everything, fill it with water, that way any attacker will drown before they can steal anything. Highly unfeasible to actually do that, right? And to have a house you want to live in unless you're some type of mer person. So, okay, that's a great point. So, other things? Yeah.
Like the context in terms of like who's using it. Like I know there are some systems at like ASU, for example, that like some submission sites for homework that are not very secure at all because only people who are like students are going to submit to there, I guess.
Yeah, or thinking about, well, for students, it's a difficult case. We think about this when we're thinking about DEF CON CTF. You have usernames and passwords to log in, but once you log in, really the only functionality, at least in qualification, you can do is submit a flag as somebody. So it's like, are we really worried about people breaking into other people's accounts so they can only do a positive action on their account? It's like, I think this thing pops up on Twitter every once in a while, of people being like, I can't believe I have to like verify my identity in order to pay my like student loan or something, or deposit money into your account. Like, no, I'd be happy if anyone wants to do this. Here's how to do that, right? So you think about risk there. The risk is insanely minimal to the person. Like, what do they care if somebody else pays off their debt or something? Yeah.
But I mean, when you, if you're paying off debt on that account, wouldn't it be possible that your payment information could be on that account? So then if someone hacks it, they could actually take
For sure, yes. It all depends on exact what information. I think the specific case I was remembering was literally just like a pay money into an account and nothing else. But yeah, it's in general, it's very easy to take a very myopic, like tiny view and say, well, this isn't important, but you forget all that other information that's there that can be used. Yeah. Yep.
So if you're trying to like deposit into your own account and you don't have to authenticate, you accidentally deposit into someone else's account.
Yeah, that's actually a good point, right? So that may be the reason for this mechanism. Is you as a person, yes, you may be fine with other people depositing into your account, but when you make a deposit, you want to make sure that goes into your account and not somebody else's just because it was easy and you mistyped some letters. Yeah. Yeah.
I was gonna say maybe the legality of it, like maybe of the situation. Like I don't know what the law says a company has to do with their security measures, but.
Oh, legal is a huge. Do you think the law is important? Do you think that companies think the law is important?
No.
Why?
Because they can get fined.
They can get fined, they get shut down, they could go to jail, right? These are all things that can happen. A corporation is usually interested in making money or continuing to exist in some form. You need money for that. You also need to not go to jail, right? So this is actually something that terrifies companies, is legal requirements. Actually, my job when I was at Microsoft was really born out of legal requirements. So Microsoft, I think it was the early 2000s, was sued for antitrust because they were considered a monopoly and were abusing their position. Does anybody know why?
Was it an internet browser?
Part of it was due to Internet Explorer, yeah.
They made manufacturers, they entered agreements with manufacturers to
yes, although those are legal, I think, well, I'm not a lawyer, let's first preface this. The browser thing, I think, was more the EU. The EU had a big problem with that because they forced Windows to include in EU software a browser selection window when they installed the operating system. So it definitely had parts to do with that. So what it turned out, yeah.
Was it because they were offering so much functionality with their OS as well? I think because they were adding in all these apps that people would normally have bought from other companies.
Right, so you think, like, the operating system provides a lot of features, right, to applications. So from Microsoft's perspective, well, just because we make a really good web browser, and do not misunderstand, Internet Explorer was a really good web browser way, 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 way back in the day. The problem is they never upgraded it to an even better web browser for like 5 or 6 years until Firefox got attention. But that's neither here nor there. But what they found out, part of the problem is they had this big operating system, which has a lot of features, a lot of system calls, a lot of things that applications could do. They found out that Microsoft was developing their own apps that would run on their operating system that were using undocumented features of the OS that other apps weren't using. And this was one of the big reasons that they got hit with this antitrust lawsuit. So much so that when I went for, I think it was, I don't know if it was intern new employee training. No, it must have been full-time employee new employee orientation. One of the things that they have an automated system that every build of every Microsoft system like looks for calls to private OS internals, and if it does that, it flags it, and that's like a high priority, high severity issue that you must fix immediately. And so how that ties into me is the group I was working in, they had this problem where now they have to either change their apps to not use that functionality, which is terrible, and takes a lot of time and effort, or write all this documentation of how to use these features. And so that's what this tool that I was working on was, a system to help technical writers write technical content. And it came out of this need, this literally legal obligation from the government, where the Department of Justice says you will write documentation for all of these APIs that they had to do and satisfy. So bit of a tangent, but it's all about, when you think about that as Microsoft, you think they sat there being like, will we comply with this request or not? Right? It's like, no, we want to be a company continuing to operate. We also want to be one company. One of the things they could have done was rip them apart like they did to AT&T, where AT&T became this big monopoly, and then they basically ripped them apart into small companies, regional companies. So this is all about, cool. So any other comments or thoughts on the cost-benefit analysis of what factors to consider? We'll talk about some good ones. Yeah.
Like the cost of implementing the security measures versus the cost of like incurring a loss to some sort of security breach without the security measures.
Yep, exactly. So cost. So that's, one of the things, but the really important thing here is to not just think of cost in terms of dollars, right? You think of dollars, you think of time, you think of economics, opportunity cost, right? The time that you have a person fixing or implementing some security mechanism is time that they can't develop some new feature which your users are going to pay you for. And then when you think about cost on the negative side, right, you want to think about all these type of costs of not just monetary costs, but all kinds of areas. Any other thoughts? Cool. So one of the parts of basically cost-benefit analysis, and this is driven by the reading I assigned on Tuesday, was looking at how do you kind of analyze the risk in a system or a specific component. And really what you're trying to answer the question is, like, should something actually be, protected or secure, right? And so what drives this decision? Flip a coin.
Percentages.
Percentages? What kind of percentages?
Well, like if you like the percent of a system failing, like what is the percent of the system failing over this period of time, and then you could pay X amount per month to keep that system updated, or you could not, depending on what you want to do with that part of the system?
Yeah, so you may try to quantify and try to understand, well, what are the likelihood that something happens. What type of assets for a company do they care about protecting? Is it everything?
Licensing.
Trade secrets, maybe?
Trade secrets? Yeah, so secrets that keep the company basically in business. What else?
User
Yeah.
information.
Just a second. So user information?
PII.
Is that?
PII.
Personally identifiable information, right? So user data that's sensitive to the users themselves, not necessarily the company. Yeah.
Controlled information.
Controlled information in what sense?
It's
Like nuclear designs and.
well, that's classified information, depending on, well,
That's true. Yes.
depending on what level. But, so it's information that isn't necessarily classified by the government as, hey, don't release this because it's a secret for the government. But it may also be information that's kind of just a category of information that's just kind of like, we don't, it's not classified, but you really shouldn't just kind of be throwing it out in the parking lot anyway. So like PII,
Right.
employee files, or even, you know, just stuff like trade secrets as well. So generally controlled information.
Nice. Yeah. Anything else? What about like the CEO's laptop? That's something they care about?
Depends on what's on it.
Depends on what?
Depends on what's on the laptop.
Ooh, depends on what's on the laptop. What do you think it takes to be worth protecting?
What can I do with the
I
laptop?
mean,
Yeah, what can you do with the laptop, right? Can you get all of the CEO's emails? Do you think that's a useful?
Can I send emails as the CEO?
Can you send emails as the CEO? Can you access internal corporate information?
there might be incriminating files.
Yeah. Yeah, incriminating files. What about like this laptop? My laptop. Am I the CEO of a company?
Potentially.
Class.
Of this
You haven't told
class.
us what you do.
Oh, so much fun. No, I'm not. But should my laptop be protected, and why?
What do you have on it?
What do I have on it? What do you think I have on it? Grades, tests. Yes, these are all things I have on this laptop. Should it be protected?
Are you going to buy an Apple product if it's not?
Are you connected to the network at ACU?
I am connected. Not right now, but yes, in general.
Probably somebody could get it.
But why should it be? I mean, yeah.
When I see that, like, should an asset be protected, I would ask who wants to take it. Like, that's
Any of you like the exams or homework assignments, the test cases?
Yes, please.
Yeah. Yeah.
Perhaps how valuable an asset is.
Yeah, so probably not. I mean, yes. So monetarily, yes. We have some servers that are worth like $20,000. It'd be very difficult to steal. I mean, not super difficult, but they're heavy. So I think you need like a crew. So legally, so ASU actually has a legal obligation to keep all of your grades confidential. That's, I believe it's FERPA requirements. So this is why if your parents for some reason tried to call me to see how you were doing in class, I have a very easy response to that of A, how'd you get this number? And B, I can't do that because of FERPA legal requirements. Also with the same thing with recruiters or something. Like unless you give me explicit permission to release that information, I cannot. And this is a legal requirement, which is why that this asset is really important to ASU, because if I lose this asset and the hard drive's not encrypted, and then somebody now has access to all the grades of all the students of all my classes, that's a FERPA violation. So this computer is encrypted. You will not guess the password, so don't steal it. So it's something that you really do have to understand the business, right, to understand what assets should be protected. Obviously, the CEO's laptop or whatever makes perfect sense. When you think about, like, I guess me versus Michael Crow, you'd think like, well, of course Michael Crow's laptop should be protected. I am not at Michael Crow's level at all, so maybe like, who cares? I'm just like a mid-level, employee at ASU. But when you realize, oh, actually this laptop has sensitive data that we have a legal obligation, then you see why the security of this laptop is very important. Mixed in with everything we've talked about, right, is what threats does this asset face, right? Why should we, and why are the threats that it faces important? How does that change your analysis of the risk? Yes. Sorry, I need like a one or a two. Let's go again.
Well, I mean, for you, we don't really have to worry about like big state actors coming after your laptop.
Right, why not? I mean, I could be worried, but is that a useful way to spend my time being worried?
Worried about what?
Big state actors. Am I worried about a big like state actor like China, Russia hacking into my laptop? No, why not?
They don't care about the grades of
Yes,
60 ASU
I
students.
hate to break it to you, but they do not care about your grades. They may be interested in research, although that's more like in the realm of movies, especially because basically all the research and all the code we write for research will eventually become open source anyways, so it would be silly to try to break into that. Maybe they'd want to break into the laptop to try to get access to DEF CON stuff to give their CTF team a leg up, but that's a little bit far-fetched, so I'm not super worried about that. So yeah, that's when I'm thinking about what threats, but what threats am I worried about? Am I actually worried about somebody breaking into this laptop? Probably not. What am I worried about? What was that?
Stealing.
Stealing, like physical theft. What else? I trust you, everyone here.
Destroying it.
Damage, but in that case, the records aren't released, so I actually don't really care. It just drops in a pile of water.
What if the one copy was on your laptop?
Yeah, that would just suck, but legally, I think I'm still good on FERPA. Yeah.
User error? So
User
if you
error. What are you
accidentally-
saying? No, just kidding.
Well, I mean, if you accidentally release all of our grades to everybody else.
If
that
I
might
share a
be-
Dropbox link to you all with all of that, the grades, that would be bad. What about just losing the laptop? Like not even theft, just leaving it in a taxi cab or an Uber or whatever, or just accidentally leaving it here. That's actually more of what threats I'm worried about than actually somebody physically stealing it, right? And so other things we think about is, so what are the consequences if it is attacked, right? So we just talked about that. So like we said, I'm not really worried about the threat of dropping this in water because I don't really care. I mean, it would suck. I guess I do have Apple Care on this, so it would get fixed, but like from a legal standpoint, those FERPA records are fine, covered in water. Other ways to think about is what level to protect an asset. Why is that important? Yeah.
Depends how important the asset is, so you like take the security measures to protect it.
Yeah, exactly. So if you're, and this goes back to the house example we talked about, right? It doesn't make sense if we're a normal person living in a house. It doesn't make sense to like hire guards to patrol the outside, to put up 12-foot, electric fences, because we don't face those kind of threats. So it doesn't make sense. The level of protection should match what we feel that the asset is, like what consequences we'll face if it's attacked, and thinking through the threats. Does risk remain constant?
No.
No, why not?
If you suddenly won the lotto and had $8 million or $800 million and it was publicized, like your name.
Yeah, my threat model might change if I told you all that I had, which I do not, that I have like 10,000 Bitcoins on this laptop. Right? That would change things. You would be very interested in coming to my office hours and seeing the laptop. So the business circumstances could change. What else?
If there's like a vulnerability that's like announced and it's like really easy to do, then maybe you're more at risk of being hacked or something.
Yeah, so when we consider, we need to constantly reevaluate, right? So we just think about what threats it faces and what are the consequences. If we're not considering the current landscape of threats, we may not be thinking about that. What else? Yeah.
If you become super popular, you get a lot more publicity,
Mhm.
and they're no longer focusing on you. So having this right into the laptop and take like pictures of it.
I will keep that in mind when I'm super famous. But yeah, it's something that people, as you have more, let's say, social standing, people have an incentive to break into your You may think that nobody cares about your phone, but if you all of a sudden become this super popular, I don't know, how much time? Oh, we're almost done? Okay, the other way to think about this is think about a company. So what do companies release every quarter?
Earnings.
Earnings reports, right? Which is how much money they made in the last quarter. Is that important information?
Yes.
Yes. Why? Yes, because it determines the price of the stock, right? Analysts actually guess on what the earnings are going to be, and then the market basically adjusts roughly to that. And then if they beat the expectations of the market, then the stock usually goes up. So if you think about that data and the data on of that financial information, right up until the moment it's publicly released is super important information, right? Strict confidentiality requirements, and I think there's probably FCC consequences. Is that FCC? No, the SEC consequences if you release that information early. So it could be insider trading or something. But that moment that it's released, that data is now worthless because it's public. Everyone can see that data. That's literally the point. So there's a temporal aspect to the risk to a system because you care about that data in that day or two leading up to the release, but right when it's released, then you don't care anymore. All right. And then, as always, how to quantify, quantification, turning things into numbers. Very difficult. What's the risk? 70%, 30%, 40%, 5%, 100%? I don't know. That's tough. All right. We'll talk for a bit on laws and customs, and we are almost done with this.